In this section, we're going to talk about identifying graphs as either linear, exponential, or neither. Now, neither actually falls in a weird category of things that we actually know. For instance, this is a graph of an absolute value equation, and this is called a parabola. You're going to spend most of Math Secondary 2 and Math Secondary 3 talking about parabolas, but for what we need to know, because in Math Secondary 1, all we talk about is linear and exponential, really, we're really going to focus on this. So when we're identifying graphs, we're either going to say something's linear if it makes a line, exponential if it has this sort of growth. It kind of looks like a hockey stick. It gets kind of starts slow and gets big quick, but it can also go down, or it can also go this direction, and it can also go that direction. Exponential, though, has a very individual look that you can always tell when something is exponential. And then this is an absolute value equation, and this is a parabola, but we don't care about that, so we're going to call these the neither. So linear, exponential, and then the neither, because these are neither linear nor exponential. So pretty straightforward, pretty simple. So really quickly on this one, before we even start reading that, I can already tell you that this is exponential, and I can tell you that this is linear because it's a straight line. But now we're going to add some more vocabulary words here. Increase and decrease. So this is a lot like the positive, negative, no slope, zero. And it always helps you, by the way, to make the little house. Put that at the top corner of your page. Kind of keeps you honest. No slope and zero. And so when I look at this, while I cannot really get it, there's a bunch of just individual slopes, but all those slopes, as I approach from left to right, are going in that positive direction. So I already know this is positive. But it also means if it's positive, that as I go, Xavier is going upwards, so he is increasing, right? So this is considered to be increasing. On this graph, as we read from left to right, as Xavier walks the graph, he's going down, so this is called decreasing. Basically, just two vocabulary words that we're adding to what we already know. Basically, if something's positive, it's going to be increasing, and if a graph is negative, it's going to be decreasing. All right? But we're going to add two more vocabulary words to that. And that is the words constant and neither again. In this case, when we're talking about it, again, we've done the slope song, right? We should know that by heart. Positive, negative, no slope, zero. Well, this is not positive, it's not negative, it's not no slope, it's a zero slope. So this slope is zero, but when it's zero, what this is doing is this slope is not changing. This is called constant. An example of constant would be like if your parents get on the freeway, they drive to a certain speed, like maybe 70, 72, then they hit the cruise control on their car, and their car doesn't fluctuate, it stays at the same speed. It's traveling at a constant speed. It's not speeding up or slowing down, it's called constant. And so this is considered to be constant. A slope of zero is always considered to be constant. And over here, if I look at my slope song, it's not positive, it's not negative, it's not no slope, it's not zero. I mean, it's no slope, not zero. A no slope, people say, well, isn't that increasing? Well, if I'm looking, when I get to this side, yeah, he's going up forever and ever and ever. But if I go to the other side, he's going down and down forever. So he's not going up or down. It's not constant because it's not going across at a steady rate. So since it's not either of those, it's called neither. So this is considered to be a neither. So there we have it. Linear equations has a constant rate of change. If the rate of change is zero, that function is called constant. So that's a quick reminder. So all we're going to do now is going to go through and see if we can put together the stuff that we already know. So I have these questions to ask. Go ahead and try it, and we'll go over it. So here we go. The first question about this graph was, is it linear, exponential, or neither? Well, that's definitely a straight line, so I'm going to go with linear. Next, I asked, is this increasing or decreasing? Well, if I put Xavier on the graph as we read from left to right, you can see that the graph is going down. So this is decreasing. Is it a function? Well, that just means does it pass the vertical line test? And this definitely passes the vertical line test. So this is a function. That's something we've already learned. And then is it so positive, negative, no slope, or zero? Well, if you just write that on your page, this is such an important thing. You can do the song or write this on your page. I can say, okay, this graph looks like the negative. Now, it might be steeper or less steep, but it's definitely going in this direction. That's a negative slope, so this is negative. And again, remember, we talked about how decreasing and negative coexist, just like increasing and positive. So, next slide, go ahead and try it. Here we go. Try it. All right, I'm assuming you tried it. Is this linear, exponential, or neither? I would say this is linear because it's a straight line. Is this increasing, decreasing, constant, or neither? Well, it's not increasing, it's not decreasing, it's not constant. Constant usually means it goes in a straight line. So this falls under the category of neither. And then, is it a function? Well, if I do the vertical line test, as I cross from left to right, when I get to this point, the line touches the blue line, infinite times. So this does not pass the function test. So this is no, not a function. And then is the slope positive, negative, no slope, or zero? And the answer is that this is a no slope. So a no slope means that it's no slope. So just by looking at the graph, this is the most amazing part. Just by looking at the graph, I can identify all these things. I'm assuming you actually already did this. So again, we look at this graph. Is this graph linear, exponential, or neither? Well, this is definitely going up at a curved angle. This looks like a very characteristic exponential graph. So this is exponential. Is it increasing, decreasing, constant, or neither? Well, as I go from left to right, looks like Xavier is going up. So that's going to be increasing. Is it a function? Well, it passes the vertical line test because it doesn't touch the line in more than one place at one time. So yes, this is a function. Is it positive, negative, no slope, or zero? Well, if it's increasing, then we know it's positive. The two things are connected. All right. All right, I'm assuming that you already did it. So here we go. Linear, exponential, or neither. This is a straight line, so I'm going to go with linear. Increasing, decreasing, constant, or neither. Well, if I take Xavier, he doesn't increase or decrease. He just stays at a constant. So this would be a constant. And is this a function? Well, does it pass the vertical line test? And the answer is yes, because it doesn't touch the blue line at more than one spot at any point. So yes, this is a function. And is the slope positive, negative, no slope, or zero? Well, if it's constant, that means we have a slope of zero. The two are connected.